So nice. I think so. We started this discussion by looking at the antenna.
Yes.
And then we came down to modulation. And so, okay. So why don't we go back and complete that discussion?
Yes. So now that we know how to send information.
Yeah.
By the way, we have still not looked at various aspects. So there are now other things that you need to take care of, right? Now we have figured out how to electronically or theoretically manipulate it.
Yes.
And we also know, we just said electronically we need a filter, and a multiplier.
Yeah.
These are the two things that we need.
Correct.
Right? And the students will learn how to do these. But actually, there are other kinds. Now we don't want to go too much into detail.
Okay.
But maybe shall we look at FM?
Sure. Quickly
look at frequency modulation.
Yes.
Because I suspect most students know about FM radio.
Yeah, exactly.
Right? So let's quickly look at what an FM signal will look like.
Yeah.
And then we can show them.
Sure.
Right?
Yeah.
So now let us say, shall we do it the way you did it? So since we are showing the slightly modern way of showing AM.
Yeah.
Right, with ones and zeros.
Correct.
We'll do the same thing for FM as well.
Yeah.
I'm sure the students will be able to pick up traditional analog style AM and FM, but this they may not see very often. So let's do it like this.
Yeah.
So now I want to send information.
Yeah.
Again in the form of ones and zeros.
Yes.
Right. So my basic information is a form of 1 and 0.
Yeah.
Right. In the case of AM radio, so we said 0 or some A, right?
Yeah.
Or in fact, this was directly the value. Or
zero.
directly 0 or 1 represented the amplitude of sine 2 pi fct.
Yes.
Okay. Now, we said we are now going to send this information on the frequency.
Correct.
Right. So, FM is what we want to look at. Now, in the case of, so we should automatically assume that there is no information in the amplitude.
Yeah.
Right. So, zeros and ones should represent something.
Yes.
Should ideally represent the frequency of the sinusoid.
Represent frequency. So, you need two frequencies.
So, you need two frequencies.
Right.
Of the sinusoid. I'll just write it as sinusoid.
Yeah.
And by definition, the amplitude, phase, etc. should be constant.
Correct.
Right? Constant. Just like that, we assume frequency is constant. Here, we'll assume constant amplitude.
Yes.
Okay. So now, this means that you are basically encoding information. The 0 corresponds to one frequency. F1. The 1 will correspond to another frequency F2.
Okay.
Okay. So the you have two states.
Yeah.
One is, so this would basically be sine 2 pi f1t.
Yeah.
And we'll say it's a constant amplitude.
Yeah.
This would be a sine 2 pi f2t.
Yeah.
So in fact, again, just like before, I have assumed that theta is constant.
Yeah.
It can be set to 0.
Yeah.
With no loss of generality. Right. So now let us draw the same kind of waveform, message signal, and see what it will look like.
Correct.
So let us say we are going to show, first we'll show the message signal.
Yeah.
So this is, I think, what did we call it? There we had A of t, right?
Yeah.
This was AM of t because it was the amplitude.
Correct.
So now we'll just call this the message.
Yes.
We'll just call this M of t, right?
Yes.
So the message M of t that we are trying to send.
Yeah.
What do you say? Shall we take the same
same waveform?
Same waveform.
Exactly.
We had 1 1 0 1 0 0 1 1.
Yeah.
Right?
Yeah.
So we'll take the same thing. So we had 1 1 0 1
0 1
0 1 0 0
1
and 1 1.
Yeah.
Right?
Yeah.
1 1 0 1 0 0 1 1.
Yes.
Right? And so on. And we want to draw, well, I think how did we, let me just look at, we should be careful about the variables.
Yeah.
We have said that M is the modulated signal itself.
Modulated signal. So
right?
let's call this as
we don't want to call this. This is
let's
the
call it
information.
A of t, A1
A
of
of
t.
t.
It's okay. Yeah.
Yeah.
It's the same thing.
Yeah, A of t. We'll just call it like this.
Yeah.
The message signal is the one which is the sinusoid.
Correct.
Right. So, if the message signal is 1,
yeah,
if the information is 1, we want to send F1.
Yes.
And we'll show it drastically different.
Yeah.
Right. So, we'll show it as if, you know, F1 is, let's say,
significantly
different.
Okay.
Right. So, the way I'll draw it, so we want to show at 1, right. So, it is F2. So, shall we say that F2 is much larger than F1?
Yeah.
Just to make the point.
Yes.
So, I'll show a very.
But F1 is also still much faster than 1 over
Absolutely.
t, right? That is
absolutely. So we also need to say that if this is t, right? If this is t,
yeah,
Tm I think is what we called it.
Tm.
If so, both F1 and F2 are much larger than 1 over Tm. That still holds.
Yeah, right.
Right. So I am doing this just for plotting.
Just for plotting this. Correct.
Okay.
Yeah. So just as to give a feel, you can, let's say we can, one Tm could be something of the order of what, milliseconds?
Let's say milliseconds.
And this could be 10 megahertz and 1 megahertz?
Sure. So
right?
it could be in microseconds.
So
basically maybe 2-3 orders of magnitude.
Okay.
That's what we are talking about. So F1 and F2 may differ, you know, by an order of magnitude.
10 megahertz, 1 megahertz.
10 megahertz, 1 megahertz.
Right.
Whereas, you know, 1 over Tm is order of kilohertz.
Kilohertz. Right. Got it.
Yeah. So, okay. So, and I'll draw this. Okay, I can just draw this in the same. So,
I think draw a different color. I think that
yes,
might be better.
That might be better. Yeah. So, I'll just show one cycle.
Yeah.
Right? Is this you're able to distinguish?
Yes.
So, now I'll something like this.
Yes.
Over one cycle, the yellow one has only one cycle over Tm. Whereas this one has 3 cycles, is the way I've shown it.
Yeah.
And then I have zeros. So I'll show it slowly varying. Oops. So now I need to draw it correctly now then. Right?
Yeah.
I have 2 zeros, so I have 2 cycles.
Correct.
Right? And then technically this is not right. Because I have said F1 is much larger than 1 over. The way I have shown it is.
It should be
much faster. Already be many cycles, but I think they
yeah, I think it's okay.
It's
for
okay.
Illustration.
For illustration, it's much harder to show that.
Okay. So this is how the frequency modulated signal looks.
Exactly. Like. So the frequency modulated signal would jump between, in this case, F2 and F1.
Yeah.
And F2 and F1 and so on.
Okay.
And so on.
Okay.
So technically, in modern parlance, this would be called frequency shift keying.
Okay.
Just like we had on-off keying there.
Yeah.
This where the sinusoid seems to go on and off. This would in modern parlance, this would be called frequency shift keying.
Okay. That's interesting. So
or FSK.
So earlier in the amplitude modulation case, between 2 sets of users, we just needed 2 frequencies.
Correct.
Now you are saying I need 2 frequencies per user?
I need 2 frequencies per user.
Okay.
But the same set of 2 frequencies can be reused by many people. Because at the end of the day, this message signal is again going to go on top of a carrier.
Okay.
Okay. When I do frequency modulation,
got it.
Again, I need a different carrier.
Oh, so that is not, okay, the carrier is different from this.
Is different from the message signal.
Okay.
So the carrier is different from the message signal in this case. So the actual transmitted signal may look like this. An example of a transmitted signal may be, let's say, A sine 2 pi FCT. This is the carrier plus M1 of t.
Okay.
Because the frequency is changing with time.
Right.
So this kind of makes the case for the frequency changing with time.
Okay. Got it.
Okay. So this is what the signal would look like.
Okay. Got it. Yeah. So this is how the FM signal looks like, and
Correct.
I'm assuming that demodulating this is slightly more involved. It's not straightforward.
Unfortunately, it's not so
Yeah,
straightforward.
it's not straightforward.
In fact, one of the reasons for AM radio being very popular in the early days was because building demodulators for AM is extremely simple. As you can see, filters and multipliers.
Multipliers. That's all.
Both of these are extremely easy,
to
cheap
build
to build.
Right.
The good thing about AM is that it's cheap, but the quality of the information, the amount of information that you can send is very slow.
Very slow.
FM can be much better.
Right.
In terms of efficiency of sending information.
Okay, great.
Yeah. So one last thing, I think, now that we have covered, theory of AM radio, FM radio. So this is basically FM radio.
Yeah.
Right. So technically, this would be FM radio.
Yes.